Okay, so the problem that we've run into several times here is one that I'm referring to as self-selection, or it's also called selection bias. And as I said earlier, I'm using this term select in a very broad way. It doesn't necessarily mean that subjects in these experiments or these studies consciously and actively chose to be in one group or another. They may have, but this is actually meant much more broadly than that. It just refers to a situation where there's um, some set of external circumstances that will consistently place subjects with some characteristics in one group and subjects with other characteristics in another group. So, coming back to this example of drinking during pregnancy, this has been studied. One of the papers I've seen was related to cognitive deficits in 4 year olds. That says defects. That is a typo. These are deficits. Defects is a pretty nasty word to refer to that. Yeah, and so what you find when you consult this literature is that women who drink heavily during pregnancy have children that are much more likely to have cognitive deficits when they're 4 years old. This is a very sad research topic, but it is important to know about. And here's the problem with this. Obviously, the children didn't choose to be in one group or another. And really, the mothers may not have either. There's all sorts of reasons why people may drink heavily or not drink heavily at different stages in their life. And the point of this literature is not to blame people or shame them, but we just want to find out about the relationship between one kind of behavior and outcomes. And we can't do this given these kind of observational data because mothers self-selected in the sense that those who characteristically exhibit some behavior, that is drinking, were systematically put in a different group than people who lack such behavior, right? So what's the problem with that? Well, sorry, pause was meant for you to think about that and try to answer that question. Well, it's possible that the difference between the children of mothers who drink heavily and the children of mothers who don't drink as heavily, maybe those differences between children were caused by the drinking, or maybe there's some other set of characteristics that accompany drinking during pregnancy that goes to explain those deficits. So, as an example, I think in this particular study, they found that mothers who drink heavily during pregnancy are also 3 times as likely to have used cocaine during pregnancy. So it's very, very hard to know what to attribute to the alcohol in studies like this because women who drink heavily during pregnancy are just different in many ways than women who don't drink heavily during pregnancy. And it's very hard to say what's causing problems with the children, given that there's a suite of other lifestyle choices that tend probabilistically to go together with drinking during pregnancy, right? So actually, the upshot of this is that when you look at guidelines for pregnant women in the medical literature, they will tell you that there is no known safe amount of alcohol to drink during pregnancy. So some physicians will tell a pregnant woman, you can't touch a drop. You can't even have a glass of wine in the next 9 months. Other physicians will say, be responsible, have a drink now and again. Don't drink every week, don't drink every day. But it's fine to have one once in a while. Why do you get this disparity? Well, again, it's in this phrasing, there is no known safe amount of alcohol to drink during pregnancy is technically true, but there's also no known unsafe amount of alcohol to drink during pregnancy. We just don't know very much about it because it's an incredibly hard thing to study. And so physicians will make personal judgments about how conservative they think people should be with regard to drinking. It's clear that probably drinking lots is really bad for babies, but reasonable people can differ about how much causation to attribute to studies like this, and you find actual medical doctors that do differ on this question. So another way of putting this, maybe these mothers didn't make a choice in some relevant sense of choice. It's not like, I mean to villainize them and make them terrible people. That's not the point here. It's just that the fact of them being in one group as opposed to the other group is not independent at all from other properties that can affect the outcome under investigation, namely how these children do as infants and young toddlers, right? So we can't say with confidence that the differences in these groups of children are due to drinking behavior rather than some other things. Another way of putting this in slightly more technical terms is that the assignment of subjects to groups is systematically biased, where bias here is not referring to the everyday concept of like, racism, or I'm biased against this group of people. Bias here is the mathematical concept of asymmetric probabilities. So there's just a difference in how likely these people are to be assigned to the group versus these people. That's what bias refers to here. This self-selection problem, or selection bias, is extremely problematic, and it pervades in almost all research involving humans, right? One amongst the many problems with self-selected groups is that the people making one kind of selection may just be deeply different kinds of people than the people making the other kind of selection. So when we're seeing differences in outcomes between two groups, those may be due to the thing that we're trying to study, or they may be due to differences in personality or behavioral proclivities and tendencies. It's impossible to say with self-selected groups like this with correlation data. So here's another classic case. For decades, at least in the United States, it was very common for parents to believe that if boys play with dolls when they're little kids, it will make them gay when they grow up. This was like a thing that you would hear fathers saying in the United States for many, many decades. And I'm sure, for some places and some people, you'll still find attitudes like this. And actually, when you look at the data, it turns out that boys who play with dolls are more likely to turn out to be gay when they're grown-ups. Similarly, for girls who play with trucks or stereotypically male toys. So these are data from a longitudinal study, and here's what this is showing. This is the females, this is the males, and here the gray bars are representing people who turn out to be gay when they're older, and the black bars are representing people who turn out to be straight when they're older. And what's on the horizontal axis here is how stereotypically male the play patterns are for them as children. Right? So what you can see here is that lesbian women are somewhat more likely to appear to the right on this graph than straight women. That means they're playing with more stereotypically male toys when they're children. Over here in the male part, you can see that men who turn out to be gay as adults, these gray bars, are slightly to the left on average from the black bars that represent straight men, and that indicates that on average, gay men are slightly more likely to have played with less stereotypically male toys as children. Right? So these are small effects. The point is not that every boy who plays with a doll grows up to be gay, or every girl who plays with a truck grows up to be gay. The point is that there's small differences between the groups, and they're fairly robust but not gigantic. It's probabilistic. So there is some truth to the idea that childhood play and adult sexual orientation are related to one another. So we do find correlational data supporting that. So can we safely conclude that playing with dolls as a young boy makes you gay as a grown man? Well, my sense is that most people in 2020 immediately understand why this idea is pretty deeply silly. Why? Why can't we conclude that from this data? Well, here's an answer. We found out, I guess, by looking out at the world that indeed there is a correlation between playing with particular kinds of toys and your sexual orientation as an adult. But the idea that if you change the toys that the kid's playing with, that it will change their sexual orientation, that's based on the idea that the relationship is causal. And that's probably not right, or more to the point, there's no evidence for that from these observational data. Why is that? Well, Presumably, there's some biological component to sexual orientation, and the exact balance between biological and cultural factors is totally controversial and hard to figure out. And I'm not making any claims about that, except that presumably there exists some kind of a biological genetic component to sexual orientation. And once we accept that, the adults from these two groups are likely genetically different, at least in some small way, then the idea that they're playing with different toys when they're kids might be due to those genetic differences, right? Maybe these kids were already, in some sense, gay or lesbian when they were doing their playing with toys as children, in which case changing the toys that they're playing with will do nothing to their underlying sexual orientation. Again, we have correlational data. It does not show causation, even though in this case, one of these sets of measurements, namely the toy play, was taken much, much, much earlier than the other set of measurements, which is their sexual orientation as adults, even though it's prior in time by a lot, right? That doesn't mean that we can conclude that it's prior in causation, because there could be some underlying factors causing both of these outcomes, right? In this case, presumably something biological, although it's very hard to know. Here's a language relevant one. People who research bilingualism, some have argued at length that being proficient in more than one language requires extensive cognitive resources related to executive function and decision making, being able to weigh and trade off information, manage cognitive resources. And they've also shown repeatedly that people who speak more than one language do better on some non-linguistic cognitive tests involving executive function and decision making than people who speak only one language. Right? And so the general conclusion you find in most of these studies is that speaking more than one language causes greater cognitive ability. So there's this huge benefit of being multilingual. And this is a conclusion you find in a lot of this literature. Question, is that justified? My answer is no, not at all. Nothing about these studies actually shows that people who speak more than one language doesn't show that speaking more than one language causes you to have greater executive function and decision making, because again, you have basically allowed people to select their own groups here. People who end up multilingual might just be different from people who don't end up multilingual. Right? Even in societies where multilingualism is the norm, you can imagine that some people are going to be more ready and more successful in acquiring multiple languages than other people. And then when they're adults and you ask them, hey, are you bilingual or trilingual? You're going to be selecting different underlying groups of people when you recruit those monolingual versus multilingual groups. And you never know whether the differences you find in cognitive abilities are because of the language or because of some other pre-existing difference between these two groups. Right? So interestingly, after I wrote these slides in the last couple of years, there's also been a big scandal in this research area where a number of researchers have tried to reproduce or replicate some of the results showing improved executive function and decision-making skills for multilingual speakers and have failed to replicate those findings. So it looks like it's entirely possible that actually this correlation itself may have been an accident or a coincidence to begin with, and there might not be anything to be explained in the first case. But even if we accept that the effects are real, I still don't think that we can actually draw any conclusions about how multilingualism does or does not improve your cognitive abilities. Excuse me, there's a helicopter passing above. Hope that's not too noisy. This is an interesting one. Keith Chen, who's an economist with no linguistics background, had a manuscript where he argued that speakers of languages that express the future tense with a special word form, that is a form that's specific to future tense, are more likely to exhibit all kinds of destructive behaviors: obesity, drinking, smoking, failure to save for retirement, and on and on and on. He argues that this is because linguistic properties can cause ways of thinking about the future that encourage different kinds of behavior with regard to planning for the future. Right? This is his argument, and it's almost surely incorrect. And there's a whole bunch of technical problems with this on a linguistic level. So basically, when he says a special word form, he's basically referring to English-like patterns where we have a special modal that we use to convey future tense, like will. He will go to the store tomorrow, versus inflectional languages like Spanish or Italian or French, where there's just a suffix on the verb that indicates future tense. And his claim is that the Spanish, Italian, French type societies have way higher rates of obesity, drinking, smoking, failure to save for retirement, and on and on and on and on and on. And that's because apparently having verb inflection instead of a special modal lets people think about the present and the future on a single continuum, or maybe I'm reversing his explanation. In any case, it doesn't really matter. The linguistic explanation itself is a mess. But let's assume that that part was completely correct and this correlation could be clearly demonstrated. If we could do that, would we be able to infer causation between linguistic structure and this cultural traits of dangerous behavior? And I think the answer is, again, pretty clearly no. Why is that? Because the languages currently spoken in any place are the results of thousands of years of contingent history, where languages spread between and within populations just like any other cultural trait. So people who have inherited a common language from the generation or the generations before them have presumably also acquired all sorts of other cultural traits from those generations besides the language itself. And that means that any difference in cultural traits that correlates with a difference in languages might be due to the language, or it might just be due to common shared history. So again, even if this observation were completely correct, which I don't think it is, it still wouldn't tell us anything about the correlation between, the causation between linguistic properties and cognitive properties or social properties, because language is, in some sense, partially a cultural property, and it's transmitted just like any other cultural trait. So of course it's going to be correlated with all kinds of cultural traits, whether or not it's even directly related to those traits. Okay, this last one is extremely general, and it's kind of controversial, maybe surprising to some of you. There's many studies in developmental psychology and education research that shows that children whose parents spend more time speaking to them or reading to them when they're small children grow up to have better verbal or linguistic or cognitive skills on some set of measurements. And this is a very robust result. It's been shown over and over and over again. Nobody doubts that this correlation exists. So can we conclude that reading to your child or speaking to your child causes them to grow up with better verbal, linguistic, and cognitive skills? This is a very pressing real-world problem. It's governing all sorts of educational interventions and actual real-world spending of money and resources. But there is a big problem here. What's the problem? Well, children are, do I have this? Right. Children certainly grow up in environments where they're either spoken to or not spoken to by their caregivers or by who are normally their parents in these studies. And in general, most of the children in these studies are living with their biological parents, and they're either being spoken to more, read to more, or spoken to less, read to less. But children are literally made out of their biological parents. And so parents who speak less, or parents who read less, or parents who are not as smart on some measure of smartness, or whatever, are going to have children who are more likely to speak less, to read less or to score lower on cognitive tests. This is a fact of biology. We are made out of our parents. Right? This is not just a problem with reading studies or speaking studies. This is a problem with literally every study in developmental psychology that only looks at observational data about the traits of parents and the traits of children. You cannot infer causation between parenting activities and the properties of children, the outcomes of children, because, again, children are literally made out of their parents. So this is a very, very general problem in developmental sciences, and it affects just about everything we know about in child development research. So what do you do about that? How can we control for genetic relatedness? And one way is to try to divorce the relationship or separate the relatedness of parenting activities from genetic relatedness, or try to look at different groups of people with different amounts of genetic relatedness. And this has been done in some areas. So here are some data from Dorothy Bishop, who's a big cognitive scientist and a language scientist, looking at the rate at which children with a sibling who's been diagnosed with specific language impairment are also likely to have specific language impairment. Here's what these pie charts are showing. These are all just made up of siblings of children diagnosed with specific language impairment, which is a kind of speech or language disorder. And what the general base rate of speech or language disorders in children is somewhere between 5 and 20%, depending on how you measure and which country or which area you're in. Yet in this pie chart here, this one is showing monozygotic twins. These are genetically identical twins. And this one is showing dizygotic twins. These are twins that share, on average, half of their genes, just like normal siblings. What are we seeing here? Well, for genetically identical individuals where one is diagnosed with a speech or language disorder, more than half of their siblings are also diagnosed with a speech or language disorder. Compare that to a base rate of about 5 or 10% in the general population. Another significant proportion of them score low on a language assessment test but have not been formally diagnosed with a speech or language disorder. Another significant proportion of them have been treated for language or speech disorders, but those problems have resolved. Some tiny proportion of them score low on general intelligence tests, and only this tiny white sliver here have completely unaffected speech and language skills. So this is strong evidence that people who are closely genetically related, in fact genetically identical, have similar kinds of profiles with respect to language and speech disorders. Now, we still can't attribute that to the genes. This still might be due to the fact that they grew up in the same house together. But here is a control group that are a lot like these twins. They're also twins, except these ones only share half their genes. Right? And the concordance, right, for speech and language disorders here is still higher than you would expect in the general population. So out of people who have a speech and language disorder and a dizygotic twin, still more than a quarter of them, those siblings also have the speech or language disorder. That's still higher than its general prevalence in the population. And you get some low language standardized test scores and some resolved speech and language issues, but it's nowhere near the proportion that you get in the genetically identical group. So based on genetically identical, 50% genetically identical, and then you could look at completely genetically unrelated people, we can begin to conclude that a lot of developmental disorders associated with language and speech have a strong genetic component to them. And this means that anytime we see a study showing that genetically related people have some correlations between their linguistic properties. In the previous example, it was reading a lot to your kid and being a good reader when you grow up. If the subjects in those experiments are genetically related, we do not know whether those correlations are due to the linguistic activity in question or whether they're due to genetic relatedness, right? And this is true of basically any study in developmental psychology. It's a pervasive problem. If you find this interesting, there's a very controversial but very well-written book on the subject called The Nurture Assumption by Judith Rich Harris, which I recommend with the proviso that it's been very controversial and some people find it upsetting. But yes. So that is my take on correlation, causation, causal inference, and group selection bias. These are really foundational issues in linguistics and cognitive science and educational research, but also in most fields that involve human beings in some ways. So these are big picture issues worth keeping in mind as you read research within the linguistics and applied linguistics areas, because you'll find these problems arising pretty frequently.